The problem is that AI is no longer deterministic. When we're talking about AI, security can't be an afterthought. Zero trust is no longer an option, right? It has to be part of the stack, from the software to the network to the edge.
There's no CV database for AI models. There is a need to have dynamic AI runtime security. So you're gonna need to have solutions out there that are using AI itself, using machine learning, so that they can adapt quickly and actually stop these types of attacks.
AI is changing the security landscape of our data center, our networks, and our user base. And there's a lot of different areas where it can impact it. And what we want to do is kind of isolate, 3 or 4 areas where we're seeing the biggest change from our customers' point of view. For me, the first one is obviously the power of generative AI in the workspace, right? The problem is that AI is no longer deterministic. It used to be you had an application, you ran a prompt, you got the same answer back every time. Where now we can go in, we can pass the same exact prompt to an LLM 3 or 4 times and get 3 or 4 different answers depending on the context, depending on what data set it's using.
Now, the second piece to that is that, as you mentioned, right, with an AI application, the same input, it's not going to be deterministic. The output that you get as a result of that input, it's going to change over time. So there is a need to constantly keep the AI model, the AI application in check to make sure that input output, it's not impacted in a negative way, and you're getting that accurate response back.
So the next topic we want to cover is really around why does AI demand security at the infrastructure level? And what do we mean by that, right? When we're talking about AI, security can't be an afterthought. It has to be built in from the ground up, and it has to be pervasive. We have to look at every kind of packet, every kind of chunk of data that's flowing and is stored throughout the environment. And what we want is something that is taking not only account data in motion, but data that is at rest as well, right? So we would need to protect all the different components from the application layer to the database, and then everything in between. So how do we do that with the existing tools that we have today?
When we say AI now demands security as an infrastructure, that means that security can't be an afterthought when it comes to the AI infrastructure and AI applications. What this means and why it's so significant is that we need to make sure we put these security functions in place now as AI evolves. 2 years ago, we had generative AI. Now we're moving to more agentic AI. And in the future, we're looking at physical AI. It is really important now that we start building our data centers with security right in the beginning. As you know, Matt, if security becomes an afterthought, it's really hard to put in security after the data center is built. You start interrupting a lot of production traffic. There's a lot more no's that you get from different groups like development team, internal IT team, any business operations that are going to say, hey, yeah, take a step back, don't implement security. So it has to go right there and from the beginning. What I would say is that there's two components to this. One is on the end user side, on your employee side. As they start using generative AI applications like ChatGPT, like Perplexity, really the main thing is we want to protect our end users. And we also want to protect company confidential information. So protecting our users is all about making sure that when they're inputting prompts, they're getting useful, accurate prompts back from whatever questions they may ask. At the same time, we don't want our end users asking certain questions that could have biases, for example, in it, or something that could end up being super harmful, right? Another case would be is you wouldn't want an employee uploading sensitive information like a statement of work, config file. There is a need to have some kind of DLP solution in place for that. Now, the second piece to that, though, is that, as you mentioned, with an AI application, the same input, it's not going to be deterministic. The output that you get as a result of that input, it's going to change over time. So there is a need to constantly keep the AI model, the AI application in check to make sure that input output, it's not impacted in a negative way, and you're getting that accurate response back.
One of the areas that we're looking at from a networking perspective is how do we implement AI in our day-to-day operations? And one of the things that we've seen some customers doing is uploading their full switch config files out to ChatGPT and saying, "Hey, how can I optimize this?" Which is a great idea in theory, but then you don't know exactly what is that model taking from that and making public, right? Obviously, they're encrypted, but it's not that hard to break dynamic depending on what kind of operating system you're using. So, we want to be very, very careful about what we're uploading. Things like IP addresses, passwords, BGP passwords, ASN numbers, all that kind of stuff provides that additional attack vector into our data center that we didn't necessarily have before, because all of that information was private.
There is a need to have that visibility that a lot of companies today, they don't have the security controls in place to make sure that they gain that visibility, and then also gain or have a solution in place to really enforce blocking so that you don't have those applications being allowed.
And so that kind of brings me to my next point, which is the democratization of models, right? We've got all these different models that are popping up all the time. They're getting updated, and you've got the big ones, which are pretty well vetted by the time they come to the market. But we've got some smaller ones that are a little less well known and maybe a little less secure.
There is no CV database for AI models. With model validation, any AI model that exists today, there are going to be ways to essentially send prompts to that model that's used for an AI application to get some response back that's not intended. It could be harmful, it could be biased, there could be sensitive data that gets leaked. There is a need to do constant model validation to ensure that the right, from the inputs, the right outputs are retrieved and the wrong ones are not sent out. So that is a constant, it's a constant work in progress that is required for AI model validation. We talk about the other part to AI models, AI applications is AI runtime security. You cannot rely totally on guardrails built into the software and into the AI application that is built by developers to just block certain prompts from not coming back, because there are ways to phrase your prompts to get information out. And that's the whole trickery that a malicious user may do to receive information from the AI application that it's not intended. There is a need to have dynamic AI runtime security. That essentially means having a firewall sit in front of your AI application to capture all the prompts and either allow them through or not allow them through. In the same fashion, when the AI application spits out a response, it also needs to be captured and looked at, and to see, does it pass my extra guardrails, I would say, to make sure that it doesn't get back to my end user if certain sensitive data is leaked out, or if there is a harmful prompt coming back that I don't want my end user to have.
How are attackers using AI to basically impact our security environment? How are they generating new attacks at the speed of AI rather than taking several days or weeks to come out with a new vulnerability attack? They can now do it in minutes or hours.
As malicious users start using AI to create malware or start attacking corporations or organizations with AI, it's really important to start adopting solutions that have AI features, ML features within the product solutions themselves. Because no human can actually go and, let's say, create policies on the fly. When you look at how fast these AI-powered attacks are being created, it's projected to happen to be able to create AI attacks with AI in a matter of 1 hour, 2 hours in the next several years. You're gonna need to have solutions out there that are using AI itself, using machine learning, so that they can adapt quickly and actually stop these types of attacks. Another part of this is also being able to collect the appropriate logs and have a SIM solution that actually has enough AI features, ML features, that can quickly correlate and identify fast enough that there is an attack and preemptively stop an attack that's happening like this.
Looking at your SIM, at your tools, your firewall logs, things like that, and being able to collate that information together and do active threat hunting, right? So and then take action based on that threat. So if we see an attack going on, we can close that specific vulnerability off, either through patching or through firewall configuration, that kind of stuff. Zero trust is no longer an option, right? It has to be part of the stack, from the software to the network to the edge.
When it comes to zero trust as well, and you have to look at entirely like the AI infrastructure. Just as an example, if we look at AI models, we want to make sure that the right team has access to the models. You don't want model tampering as an example. You want to make sure that there's integrity around which model is being used. When you look at the data side of it, you want to make sure that only the right people have access to data. And it has to be segregated. When it comes to whoever's managing Kubernetes clusters, that you need to make sure that the right team has access. If any of this access is in the wrong hands, you could basically shut down your entire AI data center.
Setting up the team with the right level of expertise means that we're able to do a couple of different things. The first one is making sure that we're doing discovery in our network today. One of the challenges that we have is customers have kind of coined the term spaghetti AI, where they have these different AI initiatives kind of all over the place, and they're all disconnected, and individual teams may be using their own little implementation of AI with a different model or something like that. How do we find and discover all the different AI components that are existing in our network today that are in use? So that's step number one. One of the areas that we find customers struggling with is these traditional silos, right? Where network team has responsibility for the network, security team has responsibility for the firewalls, application team has responsibility for development work, right? From a network team perspective, I don't necessarily, you have the security CISOs who manage things like compliance audits and security policies throughout the infrastructure, but we don't necessarily have those people implementing that at the network layer. So it's really important to have a team, a collaborative effort that goes out and looks at all of these different pieces and then has that end-to-end visibility and responsibility to put all of that security in place.
Whenever you migrate a firewall for a customer, you need to not just know about firewall policies, you need to understand the network as well. You need to understand routing, because if an application doesn't work, as a firewall engineer, you can't say, I don't know what's going on upstream, downstream. I don't understand routing, because you would need to know, hey, is traffic flowing from and to? In the same fashion, I feel now with companies adopting AI infrastructure and creating their own AI applications, it's very important for security engineers to also not only understand the network, but also understand AI, understand data, understand what are the software components, what are the hardware components involved in AI infrastructure itself. To your question, Matt, that's how we have to train our teams up. It's not like when you look at, say, AI workload security or workload security, you need to understand a little bit about the software development lifecycle. You need to understand what's exactly going on in that AI workload, because as you talk to development teams, you can't just plop a security application onto, like, say, a Kubernetes cluster and expect things to work or expect them to embrace it until you actually understand what's kind of going on in their world.